The vector product, also known as the cross product is a mathematical operation that takes two vectors in three-dimensional space and produces a third vector that is perpendicular to the plane formed by the original vectors. Definition. For two vectors math of A and math of B in three-dimensional space, the cross product math of A times math of B is defined as math of A times math of B equals begin V matrix math of I and math of J and math of K A underscore X and A underscore Y and A underscore Z B underscore X and B underscore Y and B underscore Z end the V matrix here math of I math of J and math of K are the unit vectors along the X, Y, and Z axes, respectively, and A underscore X A underscore Y A underscore Z and B underscore X B underscore Y B underscore Z are the components of vectors math of A and math of B resulting vector. The result of the cross product is another vector given by math of A times math of B equals left A underscore Y B underscore Z A underscore Z B underscore Y right math of I left A underscore X B underscore Z A underscore Z B underscore X right math of the J plus left A underscore X B underscore Y A underscore Y B underscore X right math of K properties. 1. Magnitude the magnitude of the cross product is equal to the area of the parallelogram formed by the two vectors. Math of A times math of B equals math of A math of B sin theta. Where theta is the angle between math of A and math of B 2. Direction the direction of math of A times math of B is given by the right-hand rule. If you point the index finger of your right hand in the direction of math of A and your middle finger in the direction of math of B your thumb points in the direction of math of A times math of B 3. Non-commutativity the cross product is not commutative, meaning math of A times math of B neck math of B times math of A Instead, math of A times math of B equals math of B times math of A Applications. The cross product is widely used in physics and engineering, particularly in problems involving torque, rot,